Hey everybody. Last time we talked about angles. Today we'll talk about trigonometric ratios of angles. We'll start with angles that are between 0 and 90 degrees. If you have such an angle that's between 0 and 90 degrees, I'll call that angle theta. You can draw a right triangle that contains that angle. In any triangle like this, the side closest to theta is called the adjacent side. The side opposite to theta is called the opposite side of the triangle. This side, the diagonal side, is called the hypotenuse. For any theta that's in this range, the sine of theta is the following number. It is the opposite side of this triangle divided by the adjacent side of this triangle. This assignment determines a function. I remember being confused about this when I was a kid, because this is one of the first functions that is not just multiplying by a number. So the function y equals 3x plus 1, that's just given by multiplying by 3 and then adding 1. And this function, you give a theta and you spit out a number. That's not given by any line. It's just a function. It's more of an exponential kind of function, actually. We'll see it later. Great. The cosine of theta is the, I meant to write down the hypotenuse over here, not the adjacent side. Cosine of theta is the adjacent side over the hypotenuse. And the tangent of theta is the opposite side over the adjacent side. Great. Let's look at a few important examples. So let's look at the example where theta equals to 45 degrees. Or in radians, this is 1/8 of a circle. So that's pi over 4 radians. Okay. So here's a picture of a 45-degree angle. Okay. Now you might notice this ratio here is independent of how long the adjacent side or the opposite side is. All that matters is the ratio. So this over here is 45 degrees. Let's say I want to figure out what the sine of theta, where theta is 45 degrees, is. Well, I can just let this side be 1. If this is 45 degrees, then this is also 45 degrees, which means that these sides are also the same because it's an isosceles triangle. So that means that a side angle. So this means that the hypotenuse is going to be the square root of 1 squared plus 1 squared, which is 2. So the sine of theta is going to be the opposite side over here divided by the hypotenuse. Similarly, the cosine of theta in this example will be the adjacent side divided by the hypotenuse. And the tangent of theta is going to be 1 divided by 1, which is 1. Okay. Nice. one interpretation of the tangent of theta that I like to emphasize, and will come up again later, is that the tangent of theta is the slope of the hypotenuse. So a 45-degree line, a 45-degree angle means that the hypotenuse has slope 1. And the tangent of theta is equal to 1 over here. Great, that's a great example. Another great example is when theta is 30 degrees. So let's draw theta is 30 degrees. Okay. So I'll turn the triangle around a little bit. This angle is 30 degrees, this is theta. Then I can do the following trick. I can draw the same triangle on top of it. This will also be 30. Well, if I do this, then this is now an isosceles triangle, which means that this is 60, then this must be 120 divided by 2, because the angles add to 180. So this angle is also 60. This angle is also 60, which means that these sides are all, this becomes an equilateral triangle. This whole thing is an equilateral triangle. Okay, so I'm going to let one of the side lengths be 1. That'll make this side length over here, that'll be 1/2. I'm going to redraw this triangle just to in this format here. Here I get this. So this side length is 1. This one is 30 degrees, otherwise known as pi over 6. And this side length over here was 1/2. What will be this side length over here? This side length is equal to the square root of 1 squared, hypotenuse squared, minus this side squared. So that's equal to 1 minus 1/4, which is the square root of 3 divided by 2. Great. I'm going to continue this example over here. From here, we know that the sine of this angle, sine of 30 degrees, that'll be the opposite side divided by the hypotenuse. So that's 1/2 divided by 1, which is 1/2. The cosine of 30, that will be the adjacent side divided by the hypotenuse. So that's square root of 3 over 2 divided by 1. And the tangent of 30 degrees, that is going to be this side, opposite side over the adjacent side. That's 1/2 divided by 3, square root of 3 over 2, otherwise known as 1 divided by the square root of 3. Great. In high school, you might have seen some of these ratios differently. You might know this as square root of 3 divided by 3. And similarly, this ratio here is the same thing as square root of 2 divided by 2. Great. Lastly, this triangle, it allows us to figure out what sine, cosine, and tangent are for theta equals 60 degrees. If theta equals 60 degrees, then the sine of 60, I'm going to draw the same triangle I had over there. This is 60 degrees. This side is 1. This side is 1/2. And this side, as before, will be the square root of 3 divided by 2. Sine of 60 is opposite side over hypotenuse. Cosine 60 is adjacent side over hypotenuse. Tangent of 60 is this side over this, which is the square root of 3. Okay, so these are good ratios to know how to derive on the spot, so well that it's always practically memorized. Sine of 30, cosine 30, tangent 30. Sine 45, cosine 45, tangent 45. Sine 60, cosine 60, tangent 60. Those are all ratios that you should know.